Welcome to this tutorial on avoiding broadcasting errors in NumPy. Broadcasting is a powerful feature, but it can lead to frustrating shape mismatch errors if you're not careful. In this video, we'll learn how to prevent these errors and ensure your array operations work smoothly every time. Let's start by looking at the most common broadcasting error you'll encounter. When you try to perform operations on arrays with incompatible shapes, NumPy raises a value error with the message. Operands could not be broadcast together with shapes. For example, you might see shapes 3x4 and 2x3 listed in the error message. This tells you that NumPy cannot figure out how to align these arrays for broadcasting. To understand why errors occur, let's quickly recap the two fundamental broadcasting rules. Rule 1 states that dimensions must be equal, or one of them must be 1. Rule 2 tells us that arrays are right-aligned and compared dimension by dimension. These rules determine whether two arrays can be broadcast together. When these rules are violated, you get a broadcasting error. Here's a concrete example that triggers a broadcasting error. We have array A with shape 3x4, containing 12 elements arranged in 3 rows and 4 columns. Array B has shape 2x3, with 6 elements in 2 rows and 3 columns. When we try to add these arrays together, NumPy raises a value error because the shapes don't align according to broadcasting rules. Let's analyze why this operation fails. Broadcasting compares dimensions from right to left. Array A has shape 3x4 and array B has shape 2x3. Comparing the rightmost dimensions, we have 4 and 3. Since 3 does not equal 4 and neither is 1, the first rule is violated. Moving left, we have 3 and 2. Again, 3 does not equal 2 and neither is 1. Because both dimension pairs fail the compatibility test, broadcasting cannot proceed. Now let's explore 4 key strategies to prevent broadcasting errors. First, always check shapes using the .shape attribute before performing operations. Second, reshape arrays using the reshape method or newaxis to align dimensions properly. Third, use transpose with .t or the transpose function to match array layouts. Fourth, add explicit dimensions using np.newaxis or the bracket : common none syntax. These techniques give you full control over array shapes. Let's see a working solution. Array A still has shape 3x4, but now array B is a one-dimensional array with shape 4. When we add them together, broadcasting works perfectly. The one-dimensional array B is automatically broadcast across all 3 rows of array A. The rightmost dimension of both arrays is 4, which matches perfectly. NumPy treats the one-dimensional array as if it has shape 1x4, making it compatible with 3x4. To wrap up, here are 4 best practices for avoiding broadcasting errors. Always verify array shapes before performing operations. This simple check can save you hours of debugging. Test broadcasting compatibility with small arrays first before scaling up to larger datasets. Use explicit reshaping to make your intentions clear to both NumPy and anyone reading your code. Finally, leverage np.newaxis for adding dimensions on the fly without creating new arrays. Following these practices will help you write more reliable NumPy code and avoid those frustrating shape mismatch errors.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.